All right, thank you everyone for making it to the last talk in our salon. So real quick, we have our last speaker of the day. And I know you can read on the screen here, Nader Zaveri, and manager in incident response and remediation from Mandiant. So looking forward to getting our last enriched knowledge here. And then after this talk, we will have the closing ceremony in the following salon, just on the other side of this wall. So without further ado, take it over.
Thank you so much. Good afternoon, everyone. As was stated, my name is Nader Zaveri. I am a manager with Mandiant as part of their incident response and remediation team. So usually that means during an investigation, there's two major teams that are deployed. There's the investigative team, understanding the storyline of the attack, and then there's my team where we come in and try to contain and eradicate the threat actor's access. Quick little agenda to go through. I'm gonna quick introduction of myself. Gonna go through the cloud threat landscape, what we're seeing right now from the front lines, and also what are some common attack methodologies either we've seen personally through our own investigations or what is kind of publicly available. And then I'll come in with a kind of novel technique that has really came into fruition in the past 1 year with the SolarWinds threat actor called the Golden Sample attack. And then we'll walk through some security best practices of how to secure the cloud to try to prevent these types of attacks from happening. And of course, ask questions as we get to the end. Just a quick introduction. Nader Zaveri, I'm a manager. I have about 14 years of security infrastructure experience. And the last 7 years I've worked in different consulting firms, with the last 3 years being with Mandiant. Just a quick housekeeping item. The case studies I'll be talking about throughout the talk, I'm gonna talk a lot about things that we've seen, and we'll try to obscure and obfuscate a lot of the data points enough so then you can't trace it back to an incident, because we will try to always keep things close to our chest and maintain our clients' confidentiality. So what is the current threat landscape for the cloud? What we're seeing is a rapid growth in the cloud and rapid cloud adoption. This is actually been highlighted even further because of COVID. When COVID happened, we saw the expansion and acceleration of people's cloud journey to the point that they were going into the cloud, and a lot of our influx in cloud IRs started to turn up as well, because it was such a fast journey into the cloud. We started seeing a lot of misconfigurations, and this is what we're getting into, misconfiguration of basic tenant settings, as well as you're making this quick journey into the cloud, accelerating this journey. There's a lot of security settings that are maybe native, or security configurations that are native, or services that are native that maybe the organization was not fully aware of. And this is where you'll have a lot of these issues around some of these incident responses. Some basic cloud stats that I like to kind of point out, just from our own anecdotal IRs, which is pretty, this hasn't been updated for the latest 2021, but I can guarantee you it's gonna be a lot higher than 11% of our IRs, which we do about 1,000 incident responses a year for organizations across the world. It's more looking like just purely from an anecdotal experience. I'm seeing about 25% having some sort of cloud component, with the significant portions being in the cloud, meaning it's not just a forensics of one EC2 instance. It means that the entire investigation, a majority of the investigation, is happening on the cloud using cloud services. The biggest and most jarring stat is 95% of the IRs we do, and that is publicly disclosed, has to do with the customer or the organization's failure in some way, shape, or form. It is not really on the cloud provider per se. It is sometimes a misconfiguration of a setting or a log that was already logged but was not really paid attention to. So that's kind of the most jarring stat. Some of the key things in M Trends of 2020, we highlighted a lot of cloud-based activities. One of them that we noticed, yes, you're getting into the cloud, you're trying to enable logging, which you have the ability to log a lot of things, but there wasn't a lot of things after that. You weren't tuning, you didn't have use cases developed to tune what's happening, and the threat detection and response portion of your logging and monitoring strategy was not as mature as when you have it on-prem. And attackers utilize hybrid environments. So hybrid environments meaning that you have an on-prem presence as well as a cloud presence. And what we've seen is attackers go pivot from the cloud into on-prem or vice versa from on-prem into the cloud. And that's one of the things that we're starting to see a lot, especially when you're really pushing for single sign-on, the ability to use your on-prem credentials instead of using localized credentials in the cloud. This is where you're going to see this even happen further. Credential management is important. We like to say it's a common phrase in the cloud security community that your identity is the new perimeter. It is not your typical fort firewall inside the office building. That is your inside trusted network. And then if it's coming from the outside, now your identity, your username, password, your access keys, that is now the perimeter to the cloud. So making sure your identity and access management techniques and security controls around that is of utmost importance. And we're starting to see a lack of granularity of policies and permissions. A lot of organizations, when they're in the cloud, whether it's AWS or Azure or GCP, they'll use a lot of basic managed policies that the cloud provider has tried to create, sometimes as a quick way for organizations to get themselves into the cloud, but maintain that. So there's not a granularity of policies. There's not a way to truly do an entitlements review of these policies and then figure out if they need to remove some of the permissions. So that what they'll do is just put in these managed policies. And one thing that AWS recently just came out with in the past 3 to 5 months, which is IAM Access Analyzer, which allows you to look at a role and see what permissions a specific user was able to accumulate throughout 90 days or so through CloudTrail logs, and based off of the non-used permissions, you can start stripping that away. And a lot of other cloud providers are starting to go that route. That way we can get a little bit more granular. The principle of least privilege, that principle, the old adage that is used throughout the time and everyone hates to hear about it, this is just as paramount as ever. Some common attack methodologies. This is really not an attack methodology per se, but of when you're seeing an organization having some of these incidents, a lot of times this is one of the main causes. Back in about 10, 15 years ago when I was first in IT, a big thing was rogue IT or shadow IT services. Where an organization will have their own entire IT department separate from the centralized IT department. This is the same thing that's happening in the cloud. This is because cloud is such a lucrative area for, let's say, DevOps people, for the agile nature of being able to do quick DevOps creations, creating applications through an agile process. A lot of organizations have DevOps being the first people getting there. And because of that issue, then we're seeing that all you need is a credit card. All you need is a credit card to get there. And with a lot of DevOps, their first priority, or even their second or third priority, is not really security. So we're starting to see a lot of applications being developed with not a lot of scrutiny around security controls within the application. And you'll have the famous internet-facing remote management servers or just IT backdoors. This is IT admins being IT admins, notoriously lazy, trying to find ways they can go and do their maintenance windows without having to get through the VPN, having an external facing remote management area. This is what we're seeing a lot. And of course, unpatched applications, unpatched Linux or Windows or any sort of applications, we're starting to see that because you've worked so hard on-prem for your patch management strategy, but because it's not a centralized form of getting into the cloud, it is a shadow method of getting into the cloud, which means you have limited visibility. Your patch management team is not fully aware of the assets that are in the cloud, which then lends itself to having things that are unpatched. Another thing is credential compromise via phishing. Yes, phishing is not out of the picture just because you're in the cloud. This is something that we're seeing a lot as an initial access vector. Phishing does not go away just because you're in the cloud. This is the reason because you can phish an organization's person, and a lot of times with cloud, when you're accessing cloud, you'll store those credentials. You'll store those SSH keys, those credential files on your device. And one of the common ways we're seeing attackers do is once they get initial access into into that person's endpoint, they'll start doing queries and searches through the entire endpoint device to find these credential files, because they're all kind of mentioned in the same type of either name, or there's certain key characteristics that you'll be able to quickly search to be able to get that type of access key or password. And once they have that, they'll just pivot straight into the cloud. Another one is credential compromise via endpoint exploits. So your endpoint is not in the clear. Just because you're going into the cloud and you're using a cloud provider's asset or resource, your endpoint is just as important and crucial. It is the thing that you're accessing the cloud. So we are seeing, once again, if you are using a username and password to go log in and being able to go traverse the internet with that same computer, the ability for you to get malware, either through phishing or just random website, to be able to, once they get to that endpoint, the same thing happens. They'll try to find those credential files. They'll try to find the SSH keys, the certificates, to be able to get into the cloud from there. Another thing is public exposure. This is probably the most common form that I'm seeing on a daily basis when I'm doing IRs. This is easily once or twice a month I'm seeing an IR that I have to do because of this. And this is because sometimes it's accidental credential exposure, sometimes it's credential exposure from a few hours that then once you have the crawlers go out, they'll be able to catch it in the cache. So this, you'll see an attacker just do their normal OSINT, open source intelligence, going through Google Dorking, going through GitHub, GitLab, going through Pastebin, and being able to catch these credentials for an organization on these types of things. There's actually tools out there that can traverse these types of GitHub repos and GitLab instances that become public for these certain key items. And once they're able to get that, they'll be able to come in, and usually you want to make sure you're not having those long-lived credentials at all times. And once they're in, they then be able to traverse and get there from lateral movement. This is a very unique one. So yes, it is common, but this is something that we're going to probably see a lot more. So cloud platform service attacking, where once an organization has this is for your more modern organization, they're using serverless apps, they're using serverless functions like a Lambda function to be able to perform things on their application. So from an attacker standpoint, they do some reconnaissance, find out what's about the application. Then once they're able to find vulnerability within, let's say, a container or of that application, they'll try to write a function code to be able to create permissions, create the credentials in that function to continuously be able to log in. And because they're writing a function, the credentials are not even long-lived, so there's being rotated each time. So they're able to then come in and do this at a consistent place, as long as the credentials being rotated, they can still do this. And this is something that we've seen a lot, and this is something I think it's going to happen a lot more with organizations already in the cloud for a long time. The next step is to be having more modern apps and modern-based apps where it's purely serverless. It's purely just code that is being ran. Hybrid cloud movement via cloud app. So this is a dual one. One is a lot of our organizations, especially financial organizations, they have a external facing app, whether it's mobile app or website, where they ask you to upload a document. You can upload a document to do some verification, and what we've seen is attackers are uploading malicious files that, if they're not being traced and not being reviewed at that cloud app level and is being downloaded on the endpoint of whoever's reviewing, that business analyst, then it does a code execution once it's turned on with some macro, or if it's a PDF, they'll have some JavaScript in the back to run whenever it is open, and that way they'll be able to run it on that endpoint, get the necessary information, be able to do some code execution, and they have that initial access. And from there, they'll go in and, of course, traverse the cloud or traverse the on-prem to then make it into the cloud. Another way of doing hybrid is if you have that hybrid identity. You have an on-prem and a cloud identity. And because of that, you'll be able to traverse either from on-prem or into the cloud. Third-party library supply chain attack. So this is, it's funny, when I was just last week, this is something that's going to hit home for us. So this is where an attack, it's very sophisticated and modern. So you'll have your application, and your application has packages. NPM being a major library package provider where you'll have your packages run. And with that, what we've seen is an attacker is able to find out information about the application through open source intelligence. Once you're able to find out, you can figure out what type of packages are being ran on the endpoint. And what this specific threat actor was able to do is put a malicious code and malicious set of functions within an already existing NPM package. And as part of the build process, the victim organization has the application go to NPM major library and then install it. And once it's installed, it installs a malicious version. And then once they have the malicious version, then they have the ability to access whatever they need. I kind of laugh at this because this just happened last week. So last week, another NPM library was just discovered that was malicious. It's the UA-parser library. And this just came out in news last week, where a malicious version of a library package that's been downloaded millions of times was turned out to have a malicious code in there, up to 3 different versions of it. So they had all the organizations who use a specific library package to go back and do the more updated version to remove the malicious code and functions. And there's a bunch of other types of attacks that I don't want to kind of get too deep into because of time, but your typical open S3 bucket or storage blob. This is still happening, and we're still seeing this all the time, where an organization maybe accidentally creates an S3 bucket, or by the very nature of how their application or their website set up, they have an open S3 bucket, but the files that they have there are not supposed to be public. Credential compromise through endpoint and phishing we've talked about, and then the third-party application. So because a lot of these applications are using OAuth types of methodologies, like OAuth in the App Store or on a Google Play, they'll be able to put in a malicious application. Either you could do that through, let's say, G Workspace and download a malicious application from their Google Play Store, or if you're using any sort of application library where you can download applications, they're also doing it like that. And this gets us into a more novel technique, and this is what we're calling what's been deemed and termed as a golden SAML attack. And what this is if it was first thought of and conceived by the CyberArk researchers in 2017. This was known in the cybersecurity community and the cloud security community as a theoretical approach and attack method of the cloud. But this really came into fruition with the SolarWinds threat actor that happened over December when when everyone the whole world stopped in the cybersecurity community because of the SolarWinds threat actor. And one of the methods they were able to abuse was the golden SAML attack. And what is that really? Before getting in there, one thing you do have the golden SAML, you can get into any cloud platform. I just wanted to kind of mention AWS, Azure, GCP as a major types of cloud platforms, but anything that uses an IDP into single sign-on into a cloud platform is vulnerable to this type of attack. So before we get into what is a golden SAML attack, we have to kind of go through what is SAML and what is a SAML type of authentication that happens. So SAML 1.0 came out in 2001, and the version that pretty much everyone uses now is SAML 2.0, which came out around 2005. And it's really based off of three things. You have your user agent, you have your identity provider, and then you have your service, your application that you're trying to access. So whenever you go in as a user, you try to go and access, let's say, AWS. When you access AWS, AWS says, hey, you have to go back to the identity provider to validate yourself. You validate yourself with the identity provider, then once you validate yourself, you then create a SAML assertion. That SAML assertion is then passed from the identity provider to the cloud provider, to the whatever application you want, and then you have access. Now, this got the CyberArk researchers thinking, and how can we be able to abuse this? Then came the golden SAML attack. They said, what if we were to get access to the identity provider and be able to extract those certificates that were already created? Then we'll be able to basically masquerade as a user by using that SAML assertion, because at the end of the day, the SAML assertion is getting passed. So we can create a kind of forged ticket into the cloud. And this is what we saw, is once they got into for example, the SolarWinds threat actor, they got into the ADFS database. Once they're in the ADFS database, they were able to extract the certificate. Once they're able to extract their certificate, they then pushed the SAML assertion, a forged SAML assertion, into the cloud, which they were able to bypass MFA. MFA is not even an issue with this because you're coming from a trusted identity provider. It's going to show MFA has already been included, even though there was no MFA prompt. So then this gets into one of the major reasons for this talk is how can we be able to detect and alert on this very novel way, because this is something that has just barely been thought of, and it was always a theoretical method of attacking the cloud, but the SolarWinds threat actor really put this into the forefront because of the fact that they were able to use and abuse this technique. So there's, one thing is we have to understand detecting the different phases of the SAML process. What are the data sources? And then, of course, alerting. So there are some different detection opportunities. And you have some log sources, such as from the identity provider on the left. The identity provider is, let's say, Okta, or some other IDP, Mobile Iron, or some other IDP like ADFS. They have logs. So you want to take the logs from your identity provider and then also take the logs from your service that you're trying to get into, AWS, GCP, Azure, or whatever cloud platform, and then be able to correlate that. If there is a specific login activity that's happening in the IDP, and that login activity is also happening in the cloud, that's a legitimate session. But what you'll notice is during the golden SAML process, that those two log correlations do not work because there is no true login happening at the IDP level. They're just, they've already extracted the tokens and then forging a SAML token later. So one way, and I'm going to use AWS as an example, is going through AWS logs. For example, you want to look at the AWS API calls and seeing those types of calls and then correlating that with your IDP. So a lot of IDPs, for example, ADFS has logs. It is something that they're continuously working on, and to improve the specifics of the logs and getting a lot more robust. But you'll be able to see majority of the major IDPs should be able to give you the logins, the users, the timestamps. And the big thing is making sure your timestamps match. It is an investigator's nightmare when we have to deal with 10, 15 different timestamps, and there's not a consistent method. Usually UTC is the standard method whenever we're doing our incident response reports. It keeps everyone in line in terms of making sure whenever we're putting a storyline together of an attack, it makes sense in a specific timeline. So for this example, you'll have your event type, your API call, you're having your user, and then you want to verify if that user has also logged in at the IDP. So if you don't see that, then you will notice that that is a forged SAML. So let's think about building out a detection. So we have the cloud service logs. If it's CloudTrail logs, if it's Azure AD sign-in logs or GCP logs, Stackdriver, then you have your IDP logs. You want to make sure your IDP logs are enforced and advanced. So for example, you need to make sure in your ADFS you're getting event IDs 1200, 1202s. You want to make sure you're getting not just the general logs, the administrative logs, that's there by default, but also some of the diagnostic logs. It's used, a lot of times it's used for diagnostics, but in terms of an investigation, more information is never bad. And then we want to aggregate it and being able to ensure that both logs are being able to be coalesced and events are being able to be correlated. And then, last but not least, you want to filter. You want to filter making sure that the MFA sessions are showing and being able to show that if you have an MFA session, it is showing that an MFA has been provided. But as I said, the golden SAML still shows an MFA session was present. So I'm going to give an example of how you would build an alert using Splunk. So this is Splunk queries. This same thing can be for any specific SIM or log aggregation platform, Elastic or QRadar, with the same principles, which is you have your AWS API calls. You want to also have for a user. And you want to put it for, let's say, an hour. And you want to keep that, making sure it's not, let's say, in the STS assume role. It is not just a general AWS account, making sure it's not a source IP being, let's say, an Amazon AWS. So then we can make sure it's coming from your IDP. And then you want to also look at the IDP authentication events. You want to see something over the previous 5 hours. Generally, MFA sessions last 4 hours. This is the reason why we created this alert to say 5 hours, and you'll be able to see if a user has logged in, and then 12 hours later, the login actually happens at the service provider. That is a telltale sign of a potential golden SAML attack. And then you want to combine the usernames across the different fields of the IDP and your cloud service provider using things like coalesce, making sure the user that's happening in the CloudTrail logs is also the same user that is in the IDP. So making sure those usernames are matching. Then you want to aggregate, both the indexes to be able to show that the timing and the different events are in a successive fashion. You should see these types of events happen in succession. So with a few milliseconds difference or a second difference, if you're starting to see that delay in hours, that's where you need to have a further investigation of what exactly is happening. And then you get the final results. You'll have the AWS. For example, this one we use ping federated as this example, and showing that if the API is showing no MFA allowed, or the output filter, you can use this for kind of looking up if a user has been able to bypass MFA and been able to filter out any sort of additional logs past that 14,400, which is that 4-hour window. Some additional resources to go through, which is around some MITRE mitigations. So MITRE's put together, since this SolarWinds threat actor has put together some specific attack detections as well as mitigations. And from the MITRE, you have your Active Directory configurations, 1047 with around audit, privilege account management, and user account management. Some additional resources. So what we've done after the SolarWinds threat actor that was able to abuse ourselves as well as a lot of other government organizations, we put together a white paper. And just yesterday, we did an update to this white paper because the SolarWinds threat actors are not stopping. They're finding out more novel ways. So just yesterday, we had a new update to this white paper where we specifically found some additional novel techniques that they're using, such as the impersonation role, as well as using cloud providers from other organizations to go into victim organizations. Now, I just want to kind of go through some security best practices, starting with governance. Something that we don't like as tech people. Governance is kind of oh man, we have to do it, but it is a necessary evil. It is something that has to occur. Something you need to have guardrails in place. You need to have that top-down approach, so then you are able to specify what exactly from the organization's policies can something happen. Because you, as a security analyst, an incident responder, you can't change. Or you can, a lot of times whenever I'm doing incident responses or just proactive assessments, you'll see organizations saying, yeah, but it's not in our policy. If it's not in our policy, I can still do it. So this is where it's very crucial to have that top-down approach. Understanding the cloud providers, and each cloud provider has their security contact field. This is key because whenever a notification comes out from, let's say, AWS or Azure, or if you have any sort of investigation that needs to occur, you can contact your security contact field. And they'll be the first ones to contact that person and then determine what exactly is happening. And then understand the compliance requirements. Based off regulatory standard, what is it that needs to occur? And then how can a cloud service provider be able to apply that if it's a native service or if it's a service that has to be a third party. Identity and access management. MFA is still very important. It is something we're seeing all the time. One thing we're seeing is people focus on MFA on console access, but they totally neglect MFA for CLI, command line interface, or PowerShell. This is something that we're seeing attackers utilize because that's how they're able to run a lot of their quick reconnaissance on a victim's organization, is using these command line types of arguments, which you'll need to have an MFA on both the organization coming in, the person coming in from a console, as well as a person coming in from a command line interface. Least privilege is still very key. I talked about it a little bit earlier. The principle of least privilege gets even enhanced more because of just the nature of identities and how they are in the cloud. Privilege accounts. So privilege account management is something that I feel like a lot of organizations are starting to lose focus on when they get into the cloud, because this is usually the byproduct of the people who are in the cloud. The people who are in the cloud, as I mentioned, are not your IT security folks. It's usually the last people to the party is IT security or cybersecurity teams or any of your security teams. The first, as I mentioned, is DevOps, and you have other teams creating their own cloud instances. And the last one is probably, one of the last ones are IT, and for sure the very last ones are security. So privilege account is just a Wild West. It's like Oprah. Everyone gets admin in this instance because best way to troubleshoot is just give the person admin access so you don't have to worry about permission issues, and you can troubleshoot an application, which is, of course, never a great thing to do. Temporary credentials. This happens all the time. So long-lived credentials is one of the biggest things, and one of the ways we've seen a lot of threat actors get access, maintain persistence, and being able to exfiltrate data. I can kind of give one specific example. I had a IR in 2019 for an organization that had their long-lived credentials exposed. And one of the things is this organization's been in AWS since 2008, 2009. These were the OGs of AWS. They had, when S3 was first conceived, they've been in AWS. So this is not a new organization barely making their cloud journey. This is an established organization. But of course, with AWS and other cloud providers, they've made tremendous movements and good movements and forward movements in the security space. But for example, this specific client, they had the older account. They called it the legacy account. And that, lo and behold, that was the account that was abused because they had long-lived credentials. So once we were able to discover that this specific credential was the one that was being targeted, we said, okay, we have to rotate it. They were like, we can't do that right away because we have no idea what's going to break because these types of credentials have never been rotated. Same thing that happens on-prem. Service accounts. That's the bane of every IT and security person's existence. Service accounts that have never rotated, during an incident, we tell them, hey, this service account is being abused by a threat actor. We need to rotate it. And then they look at us with a blank face and say, we can't do that right away. We have no idea the impact it could have. And this is something, happens on-prem, it's happening in the cloud. Privileged access workstations. As I mentioned, your endpoint is very key and vital to getting into the cloud. So one of the things you want to do is protecting your credentials and protecting your endpoint. One way to do that is using a privileged access workstation to get into the cloud. So you're not using your day-to-day workstation that you're going on the internet, checking emails. So then you remove the ability for phishing type of compromises or having a malware that you get on your own machine. You're actually logging into a separate bastion host or a privileged access workstation, a PAW machine, and then logging in from there into the cloud provider. And when you have the best way to do that is if you have only a few bastion hosts that gets into the cloud provider, you can create IAM policies to say, I only want these 5 or 6 IPs to log into my cloud provider. So then you don't say, I want a 10.0.0/8 ability to log in, which if it's an internal login, you specify IPs. Configuration management. So configurations are going to be key, and it's where you're going to be able to restrict users' access. I just kind of talked about it a little bit earlier. Legacy authentication protocols. So back in pre-COVID days, it was supposed to end early on in COVID, legacy authentication for M365. Because of COVID and everyone's pushing themselves to the cloud, they actually try to walk that back, and now they've recreated a new deadline of 2022. But legacy authentication, why is legacy authentication bad? What is so legacy about it? These authentication types, IMAP, POP, cannot take multi-factor authentication. It's just a legacy authentication protocol. And because of that, you want to kind of remove yourself from it. So there's a nice way within, let's say if you have Azure M365, you can look at your Azure AD sign-ons. If you go to sign-ins, you go to user sign-ins, you then go to client apps, there's 13 different applications that are considered legacy right now that you can check the boxes to see successful type of sign-ins and see which applications are doing these types of legacy authentication or which individuals. Most of the newer phones, like an iPhone that is newer, they are going to use a modern authentication. But if you have an older version of a phone, an older iOS, it'll use an older version. It'll use like ActiveSync. Application security DevOps. Because DevOps are the first people to the cloud, this is something that is so pertinent and so vital. You want to prevent those credentials being committed in code. Hard-coded credentials is still an issue even in the cloud. You're going to see people have credentials and access keys in application and code repositories. So you can create things like a pre-commit hook. So whenever a developer is committing their code in a repository, you can use something, an open source tool, or now the newer tool. So open source tools like Get Secrets, and you can create a pre-commit hook. You use Get Secrets, and whenever you commit a code, it runs Get Secrets to see if there's any code in the any credentials in that code that was just committed. Once it is clean, it'll push the code. But now with GitHub Enterprise, they just went general available, which allows an organization to scan their repositories natively with GitHub Enterprise to be able to see if there's any credentials, any sort of access keys, any certificates, any RSA certificates, anything that is on the repository. Scanning infrastructure as code. We know infrastructure as code is going to be one of the big things because that is the future, right? You want to take as much cooks out of the kitchen. So you don't want any DevOps person or anyone to be able to spin up an EC2 instance or spin up an RDS instance. You want to have that doing through, let's say, infrastructure as code, Terraform templates, CloudFormation templates. But even then, we're starting to see that code is being injected, hard-coded into these types of templates and files. So you want to also scan those types of code. You can scan it with open source tools. CFN-NAG for CloudFormation templates, TerraScan for Terraform templates. AWS just came out 2-3 weeks ago with the ability to use CFN-NAG as a native tool to review and scan your CloudFormation templates. So you're starting to see a lot of these cloud providers trying to proactively secure their platforms and give the organizations as much time. But remember, I do this on a daily basis. I try to keep up with the news. It's even hard for me to keep up. So these types of new services that come out that they're trying to push around security, that's not relayed to your DevOps person. That's not relayed to even the security folks. So it might be there. It might be present for years or half a year, but maybe your organization is not utilizing it because it just kind of falls down and kind of loses traction. Data and secrets protection. So dummy data, being able to rotate access keys. I always say treat access keys like passwords. You always want to monitor for secrets that are being leaked, and always have a plan to revoke and rotate. Go through a tabletop exercise. If you were to find a access key, can you rotate that right away? Or are you scared that if you were to rotate this access key related to this major application, that it's going to have a major impact? Always try to do these types of disaster scenarios, either from an incident or disaster recovery standpoint. And you definitely want to use resource tagging as much as possible. So resource tagging with the ability of using security-based resource tagging. A lot of organizations use resource tagging for just your general kind of billing. So if it helps with billing this department, this group, let's try to go and tag those specific resources. Now you want to use resource tagging for security purposes. If it's a critical function, it's a sensitive data, if it's specifically related to this group, for example, you can go down to resource-based tagging for a specific group and which developers are working on which projects. This is where you get past the RBAC model, which is role-based access control, and get into the ABAC, attribute-based access control, which is technically going to be the future of how you want to provide access and control within an environment. And you want to also do encryption, of course, not only at rest, but sometimes in motion, depending on your regulatory requirements. Whenever you're having it on, let's say, storing something on an S3 bucket, you can easily encrypt it at the S3 bucket level, but maybe you need to encrypt it before it gets to the S3 bucket, right? So then using a client-side encryption instead of just a managed encryption at the cloud provider. Threat detection and response. So we've talked about this quite often throughout the talk, as this is kind of the main purpose. Enable logging features, but also enable object-level logging features. For example, the S3 has your general server access logging. And then you have your object level logging, which then gets it a lot more granular. And you want to also aggregate logs into a SIM. So what we're starting to see is they're enabling logs, but it just sits in the cloud provider. It hasn't made its way into their centralized SIM where the on-prem data is at. And you want to also be able to correlate rules between the on-prem and cloud to see when those types of accesses are occurring to be able to do these types of golden SAML type of scenarios. And you want to always do specific use cases and playbooks for a cloud-based incident. How can your organization respond to a credential that's been exposed in the public internet, or a phishing that's happened that now they have SSH keys? Can you rotate those SSH keys? Are those SSH keys common across multiple types of hosts? Or are you using something like SSM to be able to have a rotation and multiple SSH keys? And that gets us right to the end with some time remaining. Feel free to ask any questions. All right, awesome. All right, thank you so much.